Look at this auxiliary engine. It's fully assembled, pre-piped, and right now it's being swung into place deep inside a cargo ship's hull. In less than 2 hours, workers will bolt 4 flanges together and the installation is done. Doing this same job by building the engine piece by piece inside the ship would take 3 weeks of grueling labor. This is outfitting. While the steel hull is the ship's skeleton, the outfit represents the internal nervous and digestive systems, the thousands of miles of pipes, cables, and ventilation ducts that bring the vessel to life. For decades, shipyards followed a strict linear timeline. You spent months building the entire steel hull on the slipway, and only then did the outfitters begin laying pipes and pulling wires. The economic reality of shipbuilding is simple. The building berth is the most expensive, inefficient place to install anything. Historically, this work was a nightmare. Steel compartments to well overhead while surrounded by other trades trying to work in the same square meter of space. Building the hull first created a logistical bottleneck. There is a physical limit to how many people you can fit inside a steel box, and for years, that limit capped a yard's total productivity. To survive, modern shipyards inverted their construction process. The goal is to keep as much work off the berth as possible. This is the 3 levels of outfit integration: unit outfitting at the base, block outfitting in the middle, and onboard outfitting at the top. The economic logic relies on pushing work downward. Completing tasks at the base yields exponential speed and cost reductions. Modern shipyards treat outfitting as a problem of spatial logistics. Moving down from the berth, we reach level 2, block outfitting. This happens in the assembly hall. Builders install major components into 3D steel blocks while they sit on the workshop floor. This large square opening in the center of the block provides a huge advantage. Because the roof hasn't been welded on yet, overhead cranes can drop massive equipment skids directly into the space. Workers are protected from the weather, equipment stays at ground level, and gravity allows fast, flat welding. Treating these steel blocks as open containers removes the physical barriers that made historical ship construction so slow. At the absolute base of the pyramid is level 1, or unit outfitting. This work takes place in dedicated, weatherproof factories. Consider the pipe spool, a fully fabricated, pre-bent section of pipe. Welding and hydro-testing this spool on a factory bench is significantly faster than doing the same work deep inside a cramped hull. On the ship, hours of fitting are reduced to simply bolting 2 flanges together. This same logic scales up to the cabin module. These are fully constructed rooms that slide into a designated slot in the steel block. The 4 walls, the plumbing, and the wiring are entirely finished off-site in a controlled environment. On the ship, workers only need to connect a water line and a power plug. Unit outfitting turns specialized marine engineering into a predictable factory process. Back at the building dock, we can see the results of this shift in strategy. The steel blocks arriving at this dock are 85 to 90% complete, packed with pre-tested systems. The very design of a modern vessel is dictated by production engineering. Steel construction and outfitting now happen simultaneously. This parallel timeline drastically shortens the journey from the first cut of steel to the final launch. By modularizing the interior, shipyards have turned a chaotic construction site into a predictable assembly line. The next step in the Masterclass journey, joining these massive, fully outfitted sections together out on the dry dock.